Okay, so hi everyone, give me 1 second, share my screen, and we'll start. Okay. All right, so welcome everyone to our Lunch and Learn session. Today we're going to be focusing on SQL, in particular the basic queries. Okay. So this is more for those of you who are new to SQL and don't really know how to work with some of the syntax of SQL just yet, right? So first thing we're going to do is we're going to go through some terminologies. Okay. So in SQL, we have syntax, which is the way that statement is written. Okay. Then we have the statement, and then the clause, the operator, and the expressions. Okay. So for syntax, it follows a very general guideline of how we can write our statements, our queries. Okay. So we have some keywords. Now in SQL, it is not case sensitive. So you could write select in all lowercase or S in uppercase and the rest of the letters in lowercase. And SQL understands that to be the same query, okay, or the same keyword. Okay. However, if you want to make it a bit easier to read, I do recommend you to use all capital letters for the keywords here, just until you get to get a hang of what the keywords are and how to differentiate a keyword from, let's say, the other like column names in your query itself. Okay. All statements we want to end it with a semicolon. Just like when you're writing a paragraph, right? We end each sentence with a period to say that this is one sentence and the next sentence starts after the period. In SQL, we use semicolon to separate the two queries. Depending on the editor that you use, and even with the language that you use in SQL, if you don't have a semicolon, the program will continue to read on to the next line until you reach all the lines or until it sees a semicolon and then process everything at once. So that will usually cause a problem because it's trying to process more than one query as one query, right? And it doesn't know what to do with that. So always get in the habit when you're done with the query to end it with a semicolon. If you do forget, when you run, you will find the errors. So just go back to where it is and add the semicolon instead. We also have the statement and the clause. Okay. So a statement is used to perform a simple task, right? And the clause is it's part of our statement itself, right? Just like, again, in English, right? Our statement is like a sentence, and our clause is like the different parts of the sentence. Okay. For today, we're going to go through some of the basic clause that you'll be using to perform some simple queries. Okay. And then later on in our next few Lunch and Learns, we will be going over a bit more advanced queries so you can build up your knowledge to work with SQL more confidently. Okay. For our operators, these are reserved keywords, right? So in all programming languages, there are some keywords that you want to avoid because those have some hidden functions or some predefined meaning embedded in them, right? So for example, in here, our operator is the words where and like, right? So they have some important functions embedded in them. So when you're naming your table or when you're naming your columns, you want to avoid these keywords, right? So you can add something to it. So let's say if you have a location, right? You want to use the where in your column name, maybe have where and an underscore or where one, right? Or just use location, right? So choose a different word instead. Okay. Some of our operators have basically computing powers as well, right? So we have our star for multiplication, we have our percentage sign for module or for kind of floor division, right? We have our greater than and equal to and less than signs for comparisons, right? And I mentioned the words like and as for logic, right? So like is a semi-mat, and we'll see that later on today. Whereas and is to say both statements have to be true, right? And its counterpart, the keywords or, means either one statement has to be true. So now that we got the terminology down, are there any questions before we move into some of the basic queries? Okay. All right. In that case, let us continue on. Okay. So for today, we're going to focus on just the basics. So how to select different rows from a table, how to select different columns, how to get the unique values from a column itself, right? And how to sort the results and how to do counts. Now, before we continue any further, I do want to mention, I will be using the words column and field interchangeably, just because technically in SQL, the columns of the table are called fields, right? So if you are more technical and discussing things with someone who's experienced in SQL, a table is made out of fields and rows, not columns and rows. Okay, so if you hear me say field, just know that that's a column. Okay? So first thing we're going to talk about is the order of operation. Okay? The first clause that the query will focus on is the from clause. So this tells SQL which table you're getting the information from. Right? So in a SQL database, there can be multiple tables. So the first thing that your SQL query identifies is where is the information coming from. Okay? Then it has a kind of where statement to filter out your records. So where is more of a row-wise reduction. So instead of reading the entire table, it eliminates some rows that does not fit certain criteria. Okay? Group by, we'll talk about this later on, but group by is to combine some of the fields so that it only produces one result for the same category. Okay. Having is, again, we'll talk about this when we talk about group by, but this is a different type of filter. Okay. It's also a row-wise reduction, but the difference between having and where is when we use it and which columns we can use them on. Okay, so again, we'll talk about having later on, but just know that there's two ways to filter out the table row-wise. Okay, and it all depends on which field or which column you're referring to, right? And how you want to reduce the table, reduce the results. Okay. Then we have the select statement. So select statement is to only choose a certain field from the table itself. Right? So instead of loading all the fields or all the columns, we select only particular ones. Okay. Then we have order by. So after we have all the data that we want, right, we have to sort it. Now it's not necessary to always have order by, but if you want to have a more kind of chronological result, it's always a good idea to add an order by in, just in case the data itself is jumbled up. Okay. And lastly, we have a limit. Now, limit is to restrict how many rows of data to display. So limit doesn't really do a filtering. It just shows that, instead of printing all the results, just print me the first few results. Right? Just like if you have a PDF file, you can choose to print out all the pages or just some pages. Right? In SQL, limit only applies to the first few. So when we put limit, we put a number afterwards, and we'll see that in our practice today. But it's saying up to that many rows. Okay. Unfortunately, in most SQL languages, there is no keyword for the last few rows. Okay. So limit is like the first few, but there is no real keyword for the last few. Right? If you do want to get the last few, you have to do some different type of query, right? To rearrange the result and then use limit again to show the first few in the opposite order. Now, even though this is the order of operations, so it's a way that the SQL language processes your query, when we write a query, it's in a different order. In particular, we actually write the select statement first, and then all the rest in the same order later. So it's only kind of the select statement that is out of place in the order here. Okay. So the first simple query that we have here is just select star. Now the star here is a wildcard, so meaning anything that matches, right? So if we have nothing following a star, it just means everything, right? So it matches everything. So every time you see select star, we're selecting all the columns from the table itself. Okay. In our from statement, you see that there are two words, right, separated by a period. So the word before the period is usually the database name. Okay. So in your SQL server, there could be multiple databases, just like in a SQL database, there can be multiple tables. Right? So if you want to specify where the table is coming from, you usually add the database name, followed by a period, followed by the table name in the database. Okay? Now, today I will show you a trick where we don't have to always type in the database name. Okay? But this only works if you're working with just one database. So if you're switching between databases, you will still have to follow this kind of format, right? So database dot table name. Now, it is recommended that you add a limit to limit the number of results that are shown. Because when you're doing a select star, most of the time you're just previewing the table. So it's not doing any analysis. It's not doing any like kind of intense look at the table. You're just kind of looking at what kind of values are there, right? Are they different data types, right? So what data type you want to use and how they're organized, right? So select star is just previewing. So if you don't have limit and you do a select star, you're losing the entire table, which is kind of pointless, right? Because you're not going to look through all the rows for the preview, right? And also in cases of big data, right? So for some of you who are interested in cloud computing or big data, most tables have thousands, if not millions or billions of rows, right? So for you to just preview the table and loading all those rows, you're wasting time and you're wasting memory. So might as well just limit it to the first 2 or 5 or 10, depending on your preference, and just look at the general trend in the output here. So a basic syntax has a select, a basic statement has a select clause and a from clause. So that is the kind of most standard statement they can have. Okay. Now, if you want to do some filtering, you could use a where clause. Right? So in a where clause, you have a condition based on one or multiple columns. For each column, you give a type of condition. Okay. So in a where clause, there is the column name followed by a comparison or some kind of keyword logic operator, okay, followed by the value. Okay, so in this case, we're looking for all the orders that have an order date greater than or later than December 1st, 2011. Okay. If you do want to have more than one statement, you will have to add things like and or to have more than one conditions to filter. Okay. Now you can see in these examples, when you're giving the values, right, you could give it as a string. So if you're comparing string values or date time values, or you can give a number if it's an integer or a numerical column. Okay. In some SQL languages, if the value is stored as a string, but is technically numerical. So let's say an ID, right, with all numbers, but it's stored as a string, but it's just numbers. When you're doing a comparison, sometimes it does work if you just input numerical values without the quotes around the string. But that is, again, not recommended because you want to stick to the data type of the column. Okay? So even though sometimes it does work, right, for consistency's sake, we still want to use the same data type. Okay? And again, I think we have an example today that will show you what I mean by that. Okay? And then for the projections, basically this is selecting specific columns. Right? These column names has to exist in the table that you're referring to. Okay? So when we call as a product ID or product category, these are two columns that are already in the product table. If you just select a column name that does not exist, you will get an error that basically tells you it cannot find that column in the table. Okay? And like I mentioned, SQL is not case sensitive. Right? So for product ID, you can have all lowercase, you can have all uppercase, or you can have the kind of proper case in this tag. Okay? The only effect that it does have is the output. So whatever case you have in your select statement for your columns, that will be the case that's shown in the output here. Okay? So if you have all lowercase, in your output, it's all lowercase. If you have all uppercase, it'll be all uppercase. Right? But SQL is able to match the column name to the table itself, right? So even if it's in different cases that's stored in the original table, it doesn't matter. And you can still find it. And again, I'll show you an example later on today where the case doesn't matter, but the output will change depending on the select statement. Okay? And just like with your limit clause, right? Where you want to just show a few rows, the select statement here will also reduce the number of columns you need to display, which will speed up your query. Okay? Because if you just want to look at particular columns, you don't want to do select star, right? Because then you have more than the necessary columns, and sometimes it's not that easy to look through the entire table to find the information that you need. Now for order by, this is ordering by the values of a particular column. Okay. Now for the default, order by is in ascending order. So if the column is numerical, smallest number on top, biggest number on the bottom. If it's a daytime, then the earliest day on top, the most recent date on the bottom. Okay. And if it's a string, it follows alphabetical. Right? And it compares letter by letter. If you do want to reverse the order of order by, there is a keyword DESC that stands for descending. Okay. So then again, numbers, it will be biggest on top, smallest on the bottom, and so on and so forth. in the order by statement, you could have more than one column to sort your table. Okay? But the order that you write the column will affect the display. Okay? So order by will go by the first column, okay, and sort the table. In that way, if there are any duplicates, so let's say for this one, there are duplicates, but the order ID column is different, for example, then you will go to the order ID column, the second column that you define, and then sort the table according to your direction. Okay? For the ascending and descending, you can apply that to each column in your order by. Okay? So you can have one column that is ascending, the second column to be descending. Okay? And because order by default is in ascending order, the ASC keyword is usually omitted. Okay? So there's really no need to add ASC because by default, it will be ascending order. Okay? However, for clarity's sake, right, especially for those of you who are new to SQL, adding ASC will help you remember that this is ascending order and another column is descending order. Lastly, we have the distinct and the count. Okay, so for distinct, it's just going to show you the unique values from the column itself. Okay, all we have to do is in our select statement, add the keyword distinct right after it, and this will filter the table so that it has only the unique values inside. Okay. Now, sometimes it's necessary to add distinct because there might be some there might be some input error, or there might be some messy data, where even though it looks the same, it's not read in the same. So what I mean by that is, let's take the example of West. Okay? Most of the time, you are expecting the region to only have the 4 letters, W-E-S-T for West. Okay? And when you display it, you're going to see West. However, sometimes, maybe when you're entering the data, right, you accidentally added a space at the end. So technically, there's 5 characters, W-E-S-T and the space. But when you display it, you're not going to see the space because it's a white space. Okay? But to SQL, the 4 character and the 5 character West are 2 different categories. So when you do a distinct, it's going to show 2 different West, and that should tell you that there is some white space characters that we're not seeing. And again, I'll show you an example of that in just a bit so you can understand what I mean by that. Okay, so sometimes you do see things that look the same, but there might be hidden white spaces that you don't see. So using a distinct will help you identify that. Now, if you were to do more than one column in distinct, what it will return is the unique pairings of the columns, right? Or the unique groupings of the columns, right? So let's say if I combine, let's say these two, for example, let's say one table has status and order property, right? If I just do select distinct, status, comma, order property, it's going to show me the unique pairings of those 2 columns. So you might see repeats in the status column. You might see repeats in the order priority column. But if you look for both columns together, this is a unique grouping. Okay? And for that, you don't need to add 2 distinct keywords in the select statement. You just have to select distinct, first column, comma, second column. And again, I'll show you an example of that in just a bit. Okay. Sorry, there's a question. So does distinct only use, yeah, so we only use distinct in the select statement. So we don't use it in the other statements, right? Because for other statements, we can use group by. Again, we'll talk about group by in another session, right? To find unique groupings, right? But for distinct, we are looking for what are the unique values in that column so that we can do more analysis later on. And then lastly, for the count, so for now, for today, at least, we're using count to look at the number of rows or the number of unique values in our table. Right? Count is technically an aggregation function. Okay? When we use count, we're only going to expect one row in our result. Okay? So it should just be a number in our result. Okay? So in this case, for the first example, when we do count star, it's going to show us how many rows there are in our table itself. And when we do count distinct, it's going to show us how many unique values there are in that column. Now, if we just do count without distinct for a column, that's going to show us how many values are in that column. So what's the difference, right? So if we do count star, it's going to show us the number of rows, but some columns in certain rows might have missing values. So you might have null values, right? But count star looks at the overall picture. So even though some columns have missing values, you still count that as a row. But if we were to do it on the column with the missing values, count does not take into account the missing values, right? So if we have a table with 10 rows, count star will say 10. But if one of the column, so let's say column A, has 3 missing values, and we do count of column A, it's going to return 7, right? So it doesn't count the missing values, it only counts the actual values that are in that column. Okay? So when you're using count, you have to ask yourself, what are you looking for? Are you looking for how many rows there are in the column, in the table, or are you looking at how many values there are in that column? Okay. Now, most of the time, when you just kind of previewing the table, when you try to get to understand the table, use a count star, which is simple, right, to get you an idea of what the table looks like. But when you're doing analysis, you might want to count on the particular column, just so you give yourself a heads up that there might be missing values, so the number doesn't really add up to the number of rows. So any questions at this time? Or any additional questions at this time? Uh, oh, okay. So I can answer that right now, but we will talk about that later on as well. But the question here is, how will the advanced functions, for instance, window functions and CTE, so kind of creating a new table, right? How would that impact the order of operations? So with window functions are inside the select statement, right? So it will run with the select statement itself. It will not run in addition to it. So it doesn't have a different order to it. It runs with the select statement. In terms of creating a new table, that will run at the end, right? So basically the CTE, all it is doing is saving the result that you see in the output as a new table in your database. Okay. Yeah, so we'll talk about that probably in another session, because today we're focusing on the basic queries to just get everyone started with SQL. Okay, but good question. Any other questions? Okay, in that case, let's do some hands-on practice. And again, just create a few simple questions for us to try out. Hopefully, it'll give you an idea of how basic queries work. Okay, so give me 1 second. Sorry. Okay, so I'm going to send you this link. Okay, so you can just copy and paste that onto your browser, and it should open up this web page. Okay, so what we're going to do is we're going to take a toy data set called employees. Okay, which can be found by just clicking on the link here. Okay. When you open it up, it would just look like a very simple kind of load statement. So give me 1 second here. It looks something like this. So we'll talk about how to write these statements again in a different session. Today, we're just using it as it is and running queries. Okay, so we'll talk about this later on. Okay, and the second link in our web page I shared is the DB Fiddle. Okay, the reason I chose this website is because we can run our SQL queries online without any installations. Okay, but if you're interested, do look into MySQL Server, okay, which is a free installation that you can download and install onto your own computer. For the editors, look at Workbench, SQL Workbench, or even DataGrip. Okay, the reason I didn't use any of those tools today is because sometimes there might be some problems with installation, and we don't have enough time to troubleshoot those. Okay, so on your own time, try to install those on your own computer so it's easier for you to work with it later on. But for our lunch and learn sessions, we'll be using DB Fiddle to run the queries online. Okay. Now, the first thing we need to do is we need to use our SQL file that we downloaded and just kind of copy and paste it into the schema SQL. Okay, so just copy that and paste it into the schema SQL. Okay, and you can run it by either clicking on the run button here, okay, which will create these tables for you. Okay, or you can just use Command Enter for if you're using Mac, or Control Enter if you're using Windows. All right. So first thing we're going to do with our new data set is to look at, well, sorry, first thing we're going to do with our new data set is to select the database. Okay, usually we do this if you have multiple databases in your server. Okay, for today, we don't have multiple databases, so we don't really need to run this query. Okay, but to select the default, so a default database, you just use and then the name of the database. So I believe here is test, not mistaken. Okay. So if you have multiple database, right, instead of doing what we saw before, where you had to write the database name and the table name, you can just have a simple use statement on the very top of your notebook or of your file, run that, and that will select a default database. So to SQL is saying that all tables you're referring to are from this database. Okay. Now, the next thing we're going to do, especially since we have a new data set, is to look at what are the tables inside the database. Okay. So to do that, we just use a so statement, and we do so tables. So it lists us all the tables in our database. Okay. So you can see here in the output, it said tables in, and this will be your database name, right? In case you don't know what the default database is. Okay. And you have the table names as each row. Again, these questions are on the links I sent you. Okay. So I just did the first one. Okay. We'll try to go through all 10, but I do want to leave some time at the end for questions. So we might stop a few ones before, but you will have access to this webpage later on as well. So do try it on your own if you don't finish it. Okay. The second one we look at is how many rows or data points are in each table. Okay. So this is our count star. Okay. So I have to select count star, and then we had to do this for each table. So we had to do from department. Okay, so that has 4. We can do select count star from employees. Okay, and this has 14. Okay, and we can do select count star from, and I'll show you how it's not case sensitive. So salary grid, grade. Did I make a mistake here? Salary grid. Yeah. Okay. Okay. This is a good thing to find out now. So yeah, yeah. So when I said the K doesn't matter, depending on it actually depends on the SQL language. So in some of my SQL languages, even the table names doesn't matter. So that is true for some of them. But in a lot of other SQL languages, like PostgreSQL, Oracle SQL, or in this case, the 5.7 MySQL, it does matter for the table. So that's something good to find out. Okay? And it's just a simple like figuring out when you said table doesn't exist, but you know the spelling is correct, right? Just change the case, right? But I'll show you from here, I guess. Right? So different capitalization, still the same function. Okay. All right. So that's the second question. The third question we have is we want to display the employee ID, employee name, and manager ID of each employee. Right. So here we're projecting only a few columns. Okay. And I'm going to delete all the queries here because you see that each query will just get added to the following and it will just get too long. Okay. So I'm going to do select employee ID, employee name, employee name, and manager ID from employees. Oh, not employee name, sorry. Employee. Okay. Now with this query, I want to mention another thing about SQL is that SQL, it doesn't end with one sentence, right? Like I mentioned, you had to end your query with a semicolon, otherwise it's going to continue on. So we can write this query in many different ways. Okay. And it doesn't matter. It reads this entire thing until you see the semicolon as one query. Okay. In other languages, such as Python, this is not the case. Right. So in cases like Python, each line is one complete statement. Okay. So if you have it this way, right, in those languages, it will just break because it's incomplete statement here. Okay. But in SQL, you can have multiple lines for one query. For the next one, I just want to use limit here for this example, right? So show the information of the first 5 employees in the table. Okay. So we just do select star from employees, limit 5. Okay. And you should see there's only 5 rows, even though we know that there is more than 5 in our table. Okay. Now, the second advice I want to give you here is, especially for new or for beginners, right? It makes your query easier to read if you separate the keywords into different lines. Okay, so here I have select statement in one line, the from statement in the next line, and then, sorry, not statement. The select clause in one line, from clause in the second line, and then limit clause in the third line, right? So each keyword is in a different line. So when I read it, it's a bit easier to read. Okay. But again, for compute-wise, this doesn't make a difference. Okay? It's just easier for you to read it, easier for you to understand the query. Okay? Now for the next one, we have display the employee names and their department ID for the employees that receive commission. Okay? So here we are looking at a filtering. Right? So if we look at the table, there's multiple different columns. One of them is commission. Okay? So basically, we want to filter based on the commission column. And if you look in the data, right, the commission columns, some of them are null, some of them have value, right? So we know that it's not going to be all the rows, it's going to be some of the rows. So we're going to select the employee name and their department ID from employees. Okay. Where commission, well, we want to have some value. So there's a key phrase called is not null. Right? So null means missing, right? So it's not null, so it's not missing. Now, one thing I want to mention here is looking through this table creation query to find out what the columns are, and to look at the data here, right? To look at what the values are for each column is kind of a cheating way of doing it, right? The correct way to find out what are the columns in the table is with a query instead of looking at the table, right? And that is a simple describe and then the table name. So describe employees. Okay, this will give you the field name or the column names. Okay, and also the data type. Okay. So if you ever are not sure what columns are in the table, use the describe statement instead of going back and looking through the table. Because sometimes you don't have access to do that. Sometimes you don't have the original creation script, right? So if you get used to this way, in your actual work, you might not be able to find out what it is. Okay. Now moving on, the next one is that are there any clerks making less than $1,000, okay, and display the salary and the name. So here we're going to do two different queries. So we're going to do select distinct. Okay. And in here we have our job name, right? So distinct job name from employees. Okay. And we see there is a clerk job. Okay. So now we're going to do a select imp name and salary from employees. Now we need to have two conditions, right? So one is the job name for it to be clerk. The other has to be the salary, right? To be less than 1,000. So we can do a where clause of job name equal to clerk, right? And salary less than 1,000. Now, when you run this query, you're going to find out something's wrong. There is no result. So it could be that these two conditions doesn't give us any results, right? That could be the case. So let's just try it with clerk. So here is kind of like a few troubleshooting for you to learn, right? So let's try this with clerk, okay? Because we know that clerk is a job name, right? So this should give us some results. So if you run this, still no results. So that's weird, right? Because in our job name, we see the word clerk, but here it doesn't give us results, right? And let's just say, okay, maybe it's case-wise, right? So maybe it's case. So let's do all capital letters, clerk, okay? but that's not the case. So it's still giving us no results. So something's wrong here. And the reason this is not giving us the results is due to the fact there are white spaces, right? So like I mentioned before, if there are white spaces, you don't see it. But these white space counts as characters, right? So to SQL, define character clerk and the actual job name clerk are different because the actual job name has all these white spaces, whereas the ones that we give doesn't have white spaces. So what do we do here, right? Well, one way is to find out the actual string, copy that and paste it, but that's not something that you can always do. Okay. The other way, since we don't know how much white space are before and after clerk, is we can use one of the logic keyword called like. Okay. So like, so it's a fuzzy comparison, meaning it doesn't have to be exact writing, but we also have to add in some special characters. Okay. So like percentage sign and percentage sign. So what this means is that this percentage sign is just like the star, but it's a wildcard character, right? Meaning that it can have any string before or after the one that we write. Right? So percentage sign is a wildcard character. Okay, so you can have any length of string, whether it's before, if we add it before the one that we put, or after. Okay. So if you do see that, right, you see that in your result where the job name does exist, but when we do it, it doesn't exist. Most likely there is white spaces, right? And we'll show you that the case doesn't matter, right? It's just because of the white spaces there. Okay, so now that we figured this out, let's add in the other condition. Okay, so we have just one person. Yeah, so the recording will be uploaded into onto YouTube later on. Let me just resend this message, or let me just copy this link for you. Okay. Right. So whenever you're doing a query, expect there to be problems, right? Especially with a new data set you're not familiar with, expect there to be problems. Okay. And don't be afraid of the problems, right? Try to think about, okay, what went wrong? How do I fix it? Right? Let me make it simpler and then do it step by step. Right. So instead of having the entire query at once, start with just a select statement, right? And then add in the where clause one at a time. Okay, and then see what the results look like. Okay. Yes, so there are functions like trim and strip that will actually there's trim. So we'll talk about those functions, I believe next, so tomorrow. Okay, during our lunch and learn. So we'll talk about different functions like datetime functions, string functions. We'll talk about that tomorrow. Okay, but yes, there are functions like that, and you can use that in your where clause as well. Okay. Um, no, I'll actually leave the other four for now for you to try. Okay, so just some advice. This one, you would be using substring instead of a datetime function. If you don't know substring, again, we'll talk about that tomorrow. Okay. For 8, you're using order by. Okay, there's some hints. For this one, unique. Anytime you see the word unique in a question, most likely it is distinct. Okay. And then for how many, right? If you're seeing that, it's a count. Okay. So I'll leave these last four for you to try out on your own because you do have the website and I'll send it to you again. Okay. Again, your data is here and the dbfiddle link is here. Okay. One more thing I want to show you is when you have distinct of two columns, like I mentioned. Okay. So let's say distinct job title and what else would be, let's say date, because I think date, there are some repeats, right? So job title and hire date, right? So I have one distinct in front and then two different columns. So this is going to give me the unique pairings. Okay, so unique pairings of the values from both columns. Right, so that's why you see there's a repeat in the job name column. But if you look across, right, these two will be two distinct groups. So for the last 4 minutes or so, I'm going to leave it up for any questions that you have. Again, tomorrow we'll talk about functions. Okay, so there are a lot more you can do with SQL than just the basic queries. But do you have any questions about the basic queries for today? Or even any questions about the plans for the future? Um, I'm not sure what you mean by project group, so I guess I'll ask Adam to answer that in the chat. But for our Learn and Learn, we're just learning some skills and practicing our skills. Okay. Okay. If there are no questions, um, in the next few sessions that we're going to work with SQL, we'll be using the same dataset. If there are other data, I will share the other dataset data with you, right? So you don't have to worry about not having it. And we will be using dbfiddle just because, again, there is no setup required. But if you do have SQL editors installed already, um, make sure you use those because that will help you practice your skills, right? Oh, sorry, there's another question. We'll talk about inner queries versus outer queries. So we do have plans to talk about subqueries, but that is in the future session. So it's not the one coming up, but it's somewhere down the line. But yes, we will talk about inner queries and outer queries. We do have plans to talk about joins and unions as well. Okay. If there are any topics that you really want us to focus on, please send us messages to Adam or to me, and we'll try to see if we can work that into a session. Um, so yeah, so I think we'll try to cover that in um, we'll try to cover that in our subquery session. So the nested queries and correlated nested queries. All right. So thank you so much, everyone, for joining today. And again, tomorrow we will have another session to go over some of the embedded functions for different data types. Okay, so if you're interested, feel free to join those as well. Other than that, have a wonderful day. Okay, and goodbye, everyone.